Just wanted to make a quick video for a customer. This is a MacBook Air 1466, and this is a 820000165 logic board. It's a good board in that it's the 1.8 gigahertz, 8 gig of RAM. So this is a very nice MacBook Air. It's a quality machine. So this came to me, and there was no light on the charger. No MagSafe light, and the reason for that was that we had a lot of damage in this area, and this happens to be the PP3B42 power supply, and this is responsible for the MagSafe light. This basically creates the 3.42 volts that turns on the SMC right here, and then the SMC communicates through this cable here to a DCM board, which the fan's right here, but there's a DCM board that sits right here. So this ribbon communicates to this DCM board where you plug in the MagSafe charger, and in this case the machine was not talking, so I knew we had problems. I saw pictures. He sent me pictures of the board before he sent the machine in, and I saw damage in this area, so I knew instantly that the PP3B42 power supply was down. There was also a little bit of corrosion on some of these tantalums, which is very common. You see a lot of water damage where you see some corrosion inside these tantalums. These are beefy pads, and it never really causes an issue. You just need to clean it. There was also corrosion, unfortunately for this customer, around these FETs that run this buck converter, the power of the CPU. Usually when these FETs fail, they don't fail, but if you get corrosion around these, usually they're very beefy and the pads are heavy because they're high current, so the corrosion doesn't eat the pads on these chips. And usually you can just clean this up and it works fine. In this case, after I fixed the PP3B42 power supply, the board didn't come up. And I was like, uh-oh. So I went ahead and cleaned all the corrosion, power washed the board, got it all ready, checked everything out, and so then I go ahead and I grab my own meter here, which I've got set right now. Let me grab my probes. I'm going to go ahead and put the ground probe in right here, because I'm one-handed, because I'm holding the camera with my other hand. I'm working on that, guys. I'm trying to upgrade my camera equipment and get a machine so that I can make quality videos, and I'm not talking into a cell phone, but right now this is what we've got. We've got the one-arm bandit here. So okay, I've got that plug in on ground. So now I'm going to go ahead and I'm going to touch this line right here, which is power to the CPU, and there's my resistance. This should be 11 to 12 ohms, not 0. And when you've got 0 ohms right here, it's a pretty bad sign. It usually means your processor's bit it. To be sure and to be safe, I went ahead and took these coils off to isolate the buck converter from the CPU, and it was still shorted. After checking the FETs, they all survived and they're fine, but the CPU is dead. And the reason it's dead is because the PP bus is what supplies these FETs on the buck converter. So one side's tied to ground, and one side's tied to the PP bus, and it's basically a switching power supply that with a bunch of caps and some inductors, it can create any voltage at once. In this case, the circuits that drive this with the feedback legs, they're driving the CPU voltage, which is 1.5 volts. But because the corrosion shorted out this one, which is the top one, this is the side that connects to the PP bus, there was 8 volts that hit the CPU, and it did it. So unfortunately, I cannot save this board with an easy repair. In the future, I would like to start changing these chips out. I have the nozzles and I can do it. The hard part for me is even finding these chips. They don't even cross properly. It's like Intel and Apple got together and custom made the CPU part number. So when you look up the CPU part number on here through the Intel ARC, you won't even find it. And I haven't quite crossed it yet. So I'm sure the only way to find these processors is going to be to pull them off dead boards. And then because we're looking at BGA rework, we have BGA rework costs on top of it. So now we're looking at a $225 repair to fix this board. But unfortunately for this customer, you know, the corrosion damaged this, which we fixed, but it also shorted out the CPU. Pretty uncommon. I don't see that very often. Like, I've seen dead CPUs from corrosion, one every 2 or 3 months. I don't see it very often. But in this guy's case, he was the unlucky one and the PP bus hit it. So I just wanted to share this video. Thanks.